We really appreciate you for being here and taking time out of your schedule. Today, we're going to talk about how multiple clouds require multiple solutions. And this webcast is based on material from the course that Eric and I authored, Sec 510, Public Cloud Security, AWS, Azure, and GCP. Some folks might have thought Sec 510. I thought that was multi-cloud security assessment and defense. Well, we rebranded to this new name and are now expanding from 3 days to 5 days. So our debut is going to be next month on February 22nd. If you'd like to join me to discuss AWS, Azure, and GCP and how they differ in more depth, please join me then or in a future live online event or on demand. Changing slide. Did I lose? Okay, there we go. We have multiple courses in the cloud security curriculum. Sec 510 is one of the courses in this curriculum. We've made a lot of new courses in just 1 year. About a year ago, only 4 of these classes existed, and now we have so many different courses specializing in different areas of the cloud. SANS is investing in the same places that your industry is investing in. Everybody's looking forward to the cloud, and so are we. So if you'd like to learn more about all of these classes, please do reach out to me. I am happy to answer the questions that you have or forward you along to the person who can answer them better. So why do we have Sec 510, a course that compares AWS, Azure, and GCP with equal dedication of time? Well, let's look at the trends between 2014 and 2019. On the left-hand side, we can see the Gartner Magic Quadrant for Infrastructure as a Service in 2014. And on the right-hand side, we have the same graph from 2019. So you'll notice 2 big changes in the trends. Firstly, there are far fewer players in the space. A lot of them have fallen off the map. And in addition to that, the top 3 players have really gained traction on each other. They're really neck and neck. AWS, still the clear leader, but Azure has made some really impressive plays over the past couple of years. And one of those plays resulted in a $10 billion JEDI contract from the Department of Defense in late 2019. So you have to take them seriously. Now, Google is certainly far in 3rd place, but they are still being used by a lot of individuals, if not as their primary cloud, as a secondary cloud. So the main reason we want to present this talk to you today is to explain that if you have a lot of experience in one of these cloud providers, you can't necessarily jump from one to the other using the same principles. These clouds were founded with different philosophies. They have different security constructs. And if you apply an AWS strategy to Azure, you may end up doing something wrong, and vice versa. So it's important for you to understand these differences when you do a public cloud security assessment. This is where you analyze the different services that your organization uses across the different cloud providers. You understand how to properly configure these services, and misconfigurations are quickly becoming the biggest security issue in our industry. And finally, with that knowledge, you can establish internal cloud security policies such that your developers are able to help you not make these mistakes out in the field. Because at the end of the day, they are the ones pushing out the code. They're the ones, in most cases, configuring your cloud infrastructure. It's important to set out those policies and to educate folks on how to properly use these platforms. So this talk is going to talk about 4 different areas in which the 3 providers greatly differ from each other. So we're going to contrast 4 different topics. We're going to start off with identity and access management, or IAM. This is arguably the most important subject in cloud security. IAM allows for you to grant access and limit access between identities and resources. So you can have individual users that interact with a service, or you can have an application that interacts with a service. In this example, we have a Dynamo database. In order to allow our application to access that Dynamo database, the virtual machine on which that application runs needs to have what is called IAM credentials. Using those credentials, they can sign requests to the DynamoDB service, and if they have the appropriate permission to perform a particular action on a particular resource, they will be able to continue performing that action and get the response from the database. Otherwise, they will get an error. So as a security professional, answering the question of whether or not an identity should have access to this resource with this action is one of the most important questions you can answer. Well, how do we define the answer to that question? We do that through these identity and access management services. AWS's and GCP's are simply called IAM, which is the acronym for Identity and Access Management. And Azure uses Azure Active Directory. Now, I know a lot of folks in the audience probably have a lot of experience with Microsoft Active Directory. Microsoft Active Directory is related to Azure Active Directory, but they are not the same service. It's not that they took Microsoft AD and put it in Azure. They are fundamentally two related services that work different. They work together, but they are two different services. So being a Microsoft expert does not make you an Azure Active Directory expert or vice versa. So let's first talk about how Iam policies are created in AWS. These are the sets of rules that define what you can access, who can access what, and with what actions. So writing statements properly is critical. Now let's look at the anatomy of an AWS Iam policy statement. It has three things. One, whether or not it should allow an action or explicitly deny that action. Two, what actions are we actually able to perform, which just defines the different services and API calls we can call. So for example, I can get an individual record in a Dynamo database. That would be an action. Or I can get an object in an S3 bucket. That'd be an action. And it's important to get those actions right. But what's even more important, in my opinion, is to get the resource right. Because just because your application needs to be able to read a Dynamo database table does not mean it needs to be able to read every Dynamo database table. And that's how you can get into a lot of trouble when you have a policy with good actions, but unbound resources. So this brings us to the difference between AWS managed policies, customer managed policies, and inline policies. Now, AWS provides managed policies, and you would think that if AWS is providing these policies to you, they would be good to use. But they aren't, because the policies have all three of those things baked into it: the effect, the action, and the resource. Now, AWS may be able to define a good set of actions. For example, they can say, hey, we have a policy for S3 read-only access. We can grant you all of these actions to allow you to have read access to S3. But how does AWS know which resources you want to grant your application access to? That's a trick question. The answer is they can't possibly predict that. They have no idea what is a bucket that is accessible to your application and what is a bucket that should not be accessed by your application. So if you look at these AWS managed policies, the overwhelming majority of them have a star in the resource section. So Amazon S3 read only allows you to perform these read actions, which may be okay, but to every single bucket and every single object in your account. And that's not a good thing to allow, because if you're storing highly confidential data in S3, your application server should not be able to read those internal memos that may be stored in an S3 bucket. So we recommend highly do not use AWS managed policies. You can use customer managed policies, one that you manage because you know the business logic for your business to define what resources should or should not be accessible. You can also do inline policies, which are attached to specific principles and cannot be reused, but do not use the policies that AWS gives you. Now, how does that compare to Azure Active Directory? Well, it's actually quite the opposite kind of scenario. We have what's called built-in roles in Azure, and we have what's called a role assignment. So a role simply has the permissions that an identity can take. In order to define who can take that action and on what resources, we need to create a role assignment. So a role assignment has three parts: the security principal, which is the identity that can take a particular action; the role definition, which defines all of the actions that an individual can take; and then the most important part here, a scope. We can define at what level is this role assigned to a security principal. So I can say, hey, Eric, you have storage account read access, but I'm going to scope that permission in this role assignment to a particular storage account. And as a result, it's okay to use Azure created roles as long as you scope them down to the appropriate resource level, and as long as you're auditing what is in that role definition to make sure that you're following the principle of least privilege. Now, don't get me wrong, you can do bad things with these built-in roles. You should not uncritically use these roles. You should know what actions are actually assigned in these roles. The owner role allows you to perform any action, full access to your resources. Now, it's definitely not appropriate to assign that at the subscription level because now you are basically an admin of the Azure account. Can you assign it to a particular blob on a particular storage account? I mean, I guess that's fine, but why use that when you could use more specific roles and scope it down both at the actions that are allowed and the resources that are allowed to be performed, that these actions can be performed on. So I would highly recommend using the built-in role with the least permissions necessary for what you want to do. But you don't need to create custom policies is really the thing we're trying to get across. You do not need to create custom roles because you can define effectively what resources are accessed outside of the role itself. That's a part of the role assignment. Now, when we compare this to GCP, GCP is even more dangerous than Azure in terms of what their predefined permissions are. They have these primitive roles that are accessible everywhere within the GCP account. In fact, they're used by default in a lot of different areas in GCP. And everybody we've talked to in GCP security says that they're bad and you shouldn't use them. And the reason why that is because the viewer role gives you read access to everything. The editor role gives you all of the viewer role permissions, plus the ability to modify anything in an account. And the owner role is everything that the editor can do, plus managing billing. These roles were the first ones that were created, and if you're using them, you probably should reconsider because they are dangerous. They have thousands of actions. The editor role, the last time I checked, had 3,500 actions. So you should use roles with less permissions. That being said, you can still use those predefined roles as long as you understand what's in those permissions, because you can scope your policy down to a specific resource. In this example of Terraform code, which is an infrastructure as code service, we are taking a policy and we are or a role, I should say, and we're binding it to a specific KMS key, saying that this service account can access KMS and has read access to KMS, but it's only going to be for a particular KMS key. So we're scoping it down to a particular level. So in summary, AWS, their built-in policies are dangerous and should not be used. The Azure and GCP built-in roles could be dangerous if you apply them at the wrong scope, or if you use a policy with far too many actions, but you do not have to roll your own roles if you are doing, if you're doing your due diligence, if you know what you're doing about scoping and permissions. Now let's transition into cloud virtual network monitoring. So we have what's called a cloud private network, which is a logically isolated network in your AWS account, your Azure account, or your GCP account. And there are there's no way to connect to that network outside of the explicitly defined connections that you put in your account. Now, we want to be able to look at what's going on in these networks at a metadata level. This is very important for digital forensics and incident response. We need to know what kind of traffic is being sent into our account and whether or not we're blocking it. So we're not going to actually store the individual messages that are sent into our VPC. That could have some privacy issues if we were able to read the individual messages that are flowing in our network, because those can potentially include credit cards and things along that nature. But we want metadata. Who's sending what messages to over what port? What are the size of those messages? What are the protocols that are being used? So we can look for indicators of compromise. So each of these clouds have a flow logging solution, but there are some critical differences between them. Let's first talk about AWS. AWS allows you to define a traffic type. You have three different options. You can do all traffic, you can do denied traffic, and allowed traffic. So you can look at traffic that's being rejected by our security group rules. We can look at traffic that is being allowed by our security group rules, or we can look at both. I generally would say log both of those things. We want to know where our protections are succeeding and where they're failing. So you can configure AWS Flow Logs to capture all of that data for a particular period of time. And you can store it in CloudWatch, you can store it in S3, you can store it in Glacier. You have a lot of options there in terms of persistence. So here's an example of one of those flow logs. For those who are not familiar, there's a source, there's a destination IP address, a source port, a destination port. So we're not looking at the message itself, but we're looking at metadata about that message, which can indicate who's trying to attack us. It can give us some threat hunting tools and indicators of compromise. And in this case, this log indicates that this packet was rejected. It was not allowed into our VPC. Now let's compare this to Azure. Azure also has the ability to provide allowed logs and denied logs. So here's an example of us querying an Azure Log Analytics workspace for network security group flow logs to find denied logs of a particular type. So we can look at denied logs and logs for allowed traffic. Now let's compare this to GCP. So here's the setup that we have for our GCP virtual private cloud network subnet or subnetwork. Here we're saying aggregate all of the metadata, 100% of the logs should be logged. So this is a percentage, 100% of the logs should be stored, and we're going to aggregate them every 5 seconds. So you would think when you're setting up this logging configuration that we're going to capture all of the logs in our VPC. Here's the problem. That is not actually true, because when you set up flow logging for a Google Cloud VPC, it is not going to show you any of the inbound traffic that was denied. Now, why is that? How could that possibly be? Well, according to their documentation, the flow logging is happening at the VPC level, which means that the flow logging service will not see traffic that is blocked by the firewall. It has no visibility into what happens at the firewall. So all of the inbound traffic that is denied will be omitted from the flow logs, and we don't know whether or not our outbound traffic will be accepted or denied. It's all behind the firewall. Now, that might be sufficient for you if you only want to look at what's coming in successfully, but I want to get all that information. I want to know what's rejected as well. So how do we do this in GCP? Well, the good news is you do have an option. There is a construct in GCP called Gcp Firewall Logging. You can log at the firewall level. But if you didn't know that these were two separate concepts in GCP, you might find out that you're missing half of your logs. So in summary, you have the same capabilities in both providers, but GCP separates the logs between VPC logs and firewall logs. And if you want to look for denied packets, you better have flow logging enabled at the firewall level. Now with that, I'm going to kick it to Eric, who's going to talk about two other subjects on this topic.
Right, thanks, Brandon. So
I accidentally advanced
here.
I actually accidentally advanced the previous slide.
All right, let's go back one. Yeah, the intro. So switching gears, now that we've covered IAM, some key differences there. We've looked at some of the VPC network capture capabilities across flow logs. We can't really have a cloud security discussion without talking about securing the storage platforms. So we put a lot of research into this, comparing not only just storage in the terms of public access, which seems to get all of the credit, but also looking a little bit broader than S3, Azure Storage, and GCS publicly accessible buckets into what other resources can be made public outside of that. As you look through AWS, as far as scanning for publicly accessible resources that could be shared through a public sharing API, or by setting a policy-based public policy using principal star as another path that you can share some resources in AWS, you actually find quite a few things. So Scott Piper, who works at Summit Routes, has a nice little GitHub repository that's just called AWS Exposable Resources. There's some amazing just research, a list, just I don't know how many, maybe 20 to 30 different resources in there. If you compare that with what something like Prowler actually looks for, which is an open source AWS security assessment tool maintained by Tony Blix, you will find that there are a lot of different resource types. Some of them are listed on the slide that can be exposed in the AWS ecosystem. Many of them are very viable exfiltration paths if you compromise an account. So if you think down the attacker perspective, if you get access keys to some AWS account and you've got permissions, for example, to create an EBS snapshot of a block storage resource, and then you can set the public permission on that, suddenly you can exfiltrate that data into your own AWS account and start doing some forensics analysis, or restore the snapshot and start looking around on disk for those things. ECR, your container registry repositories, queues, notifications, Redshift clusters, Lambda functions, a lot of these things that aren't commonly talked about in terms of just securing public access to resources are underappreciated, I think, by the security community, and maybe overlooked in a lot of cases. So it's really something that Prowler and I think Scott Piper's repo do a great job of highlighting, and something that we put some effort into including in this material, so you can start investigating those resources in your own account. A lot of work. Almost completely opposite of that, if you look at Azure, it's very interesting. There's very little that you can share publicly. So you've got your Azure storage containers. Yes, they have a public option on them. But if you look bigger than that, so I tried to make disk snapshots and share them to the world, couldn't do it. I tried to create virtual machine gold images, share them with the world, couldn't find a way to do it. And the reason for it is because the underlying technology that Azure's using for most of this is storage. So if you go into your Azure policies and you set up a global, more subscription level policy that blocks public storage on the Azure Storage API and just say, we cannot do that, the only way to really share a lot of this information is by using signed URLs. So to share a virtual machine, for example, you can share it with other folks. I can give Brandon a URL that is signed and valid for an hour, for example. And in that hour, he can download that disk snapshot locally, but then it expires in an hour. So it's not a long-lived public share like some of those things are on the AWS side. So a little bit better of a model, in my opinion. It does highlight the fact that you should be very concerned about activity in your account creating shared access signatures. So it's something that we put a lot of time into researching, as far as actually all clouds, as far as AWS, Azure, and GCP, and determining what does the log data look like when a shared access signature is created. Can you detect those being created in your account? And two, what does it look like when somebody uses one? Can you detect actual incoming requests with these signatures on them to figure out if maybe one got leaked accidentally, or if an attacker is using those SAS tokens to exfiltrate data? So we'll show you a couple of examples in the demo here where we'll look at an AWS version of this and see how we can potentially detect those things. On the GCP side, it's somewhere in the middle of Azure and AWS. I'd say there's by far less things that you can share publicly in GCP, but there's still some that you should be worried about. Disk snapshots can be shared publicly. BigQuery data sets can be shared publicly. Obviously, you've got storage that can be shared publicly, but there's a good control over there too. There's an org policy in GCP that allows you to set up domain restricted shares. So you can actually put in an approved list of domains to say, all right, my company, Johnson Consulting, and Brandon's company, Brandon Consulting, or whatever. You can put 3 or 4 domains in there. And then that's the only domains that GCP across the organization will let you share things with. So you can eliminate a bit of that exfiltration path to custom partners or maybe companies that you've acquired and control it at a higher level over in the GCP platform. Here's an example of me sharing the BigQuery data set with everybody. Now, this is an empty data set, so good luck. Go find it, see if you can dig anything out of it. But that was just another resource where all users, which is kind of the GCP way of saying everybody, that's equivalent to the principal star permission on the AWS side, can access this particular resource. URL signing can still happen over in GCP as well. So there's a gsutil command where we can say, okay, let's sign this URL. It's valid for 10 minutes. You do need an actual service account key. So you see that sec510 key.json file to produce shared access via URL signing over in the GCP world. So there's a little bit of a control there. If you deny the ability to create those service account keys at an org level, well, you've kind of fixed this problem, but it could be something that maybe we should watch a little closer. We've also got some audit logging there as well. So that's just another example of sharing things publicly, which could be a nice exfiltration vector in the GCP side. So the snapshot across the 3, as I mentioned, AWS, very simple to share a lot of different resources publicly. GCP falls in the middle. There's by far less. GCP has a really good control for this, where you could argue AWS's is a little more distributed and it's not seamlessly implemented across all of those services I mentioned. And then Azure has a great subscription level policy for blocking storage, and then you're just really worried about shared access tokens, sharing those things out. So very easy snapshot comparing those two together. We venture a little further into the material in Sec510, and we land ourselves in the final discussion of the course, really focusing on, okay, we've covered hundreds of different compliance benchmarks and best practices and cloud misconfigurations that we need to be looking for as you perform these assessments. And in the final section, we discuss, well, how can we do this faster? And maybe how can we leverage some automated tooling within the accounts to detect some of these misconfigurations a little bit better? So we look at the cloud native services that are available. So AWS's Security Hub, Azure Security Center, GCP's Security Command Center are the 3 comparable offerings inside of those different providers. As we look at Security Hub in a little bit of detail, and as I really went through all of the capabilities and all the documentation, I was pretty impressed by how mature it actually was, considering how young it is compared to the other 2, which were there a little bit earlier. In Security Hub, there's a couple of different foundational benchmarks that you can set up. They're all AWS config based. So you have to understand you're using config behind the scenes, whether you wanted to or not. So there's some charges from config to do the resource evaluations to go along with this. But right out of the box, you can enable config, write about 3 or 4 lines of Terraform to say, turn on the AWS foundational security best practices which gives you full CIS benchmark coverage plus another 50-ish config rules, looking for a lot of those public resources as well as misconfigurations. There is a PCI benchmark as well. And one of the coolest parts in Security Hub that I ran into is the fact that there's a lot of great integration capabilities inside of the service as well. I mentioned Prowler earlier. Tony Blix was on a webcast with us back in October where he kind of announced that he was getting his open source project Prowler included as an integration inside of the AWS Security Hub dashboard. And the way that he's doing that is obviously had to register with Security Hub, but all of the data from his scans are being passed up to Security Hub through an API. And we're all capable of calling that API in our own accounts if we want to. So you can write your own custom scanners, your own custom rules, find problems even manually, and you can add them to the Security Hub dashboard just by formatting your results in the AWS security findings format and passing them up to the REST API. And you can start adding your own data from your own processes to those dashboard checks that you've got in place in your account. So pretty powerful feature there. A lot of really good integrations from the vendor perspective. There's tons of vendors, think container security vendors, monitoring vendors, et cetera, that all have integrations available inside of AWS Security Hub. Azure Security Center does a really good job at compliance. I don't think anybody's surprised by this. Microsoft has been in the compliance game for a long time. There's a reason they won that JEDI DoD contract, and it's because from a compliance perspective, that's what they do. Now, this is not even all of the compliance policies that are inside of Security Center. If you turn the full offering on, so you need Azure Defender in order to do that. The baseline is their Azure security benchmarks, which have some of the Azure CIS benchmarks, plus some of their own benchmarks that they felt were gaps in the CIS list. But it's also got ISO 27001, PCI, the SOC Trust Service Principle, TSP, baselines are in there, and many, many, many more for you to go in and use, depending on what industry you're in. You can also build your own custom policy. You can build a custom policy that looks for resource violations that way. And you can also kind of mix and match some of the checks from these other compliance policies or regulatory lists and kind of build your own from it. So I'd say out of the three, that's probably the best from a compliance perspective. Integration wise, there's not really any integration capabilities that I saw there or a REST API to add custom findings, but you can add your own custom policies that would essentially become a custom finding if you build one out, if that makes sense. So very different than Security Hub, but I would say compliance wise, that's probably going to win of the three. GCP's Security Command Center, I think, is a very good representation on the free tier of looking for just the super, just egregious basic misconfigurations, right? They're going to yell at you if you've got a public storage bucket. I want to say in the free tier, you've got something like 10, maybe 15 max checks that it's going to look for you on the free tier. It gets interesting over in GCP's Security Command Center when you go to upgrade it. So in AWS and in Azure, you can turn on all the features from Terraform, and you'll start getting billed for it. But you can turn it on in Terraform and then turn it off in Terraform because it's kind of an on-demand pricing model. If you don't like how many config rules came out there, then shut some off. If you want Azure Defender threat intelligence or their agent running on a couple of your VMs just for a month to get some telemetry, you can do that, shut them off. So GCP's Security Command Center, the premium tier, you have to call them and essentially talk to your account rep to get that thing enabled. And based on the documentation, the pricing for that is a minimum of 25,000 US dollars per year, or the higher of 5% of your cloud bill. So if that gives you any indication on what you probably need to be spending in the cloud per year in order to turn this on, that's kind of, at least it separates the startups from the enterprises. I'll put it that way, at least to get access to that. If you do turn it on though, you get hundreds of rules and you get a massive mapping of command center to their GCP CIS foundational benchmarks. The mapping to PCI comes into play, NIST 853, ISO 27001, etc. But in order to meet all those, you've got to upgrade to that premium security health analytics offering. So a little bit different on how that one is implemented. Here's the overall service comparison, kind of the pay-as-you-go model over with Security Hub and Security Center in Azure. And then when you pop over to GCP, comes with a price tag, but a really awesome service. One of the things I didn't mention about command centers, it's also got some container threat intel built into it. So it's got some Kubernetes cluster Docker image inspectors available to even kind of give you some of that telemetry down in your workloads as well. So comes with a cost, but it's got some pretty cool features. Okay, with that, Brandon and I wanted to walk you through a little bit about the Sect 510 lab environment. I know if Brandon was on here, he would say, I don't know how many hours of blood, sweat, and tears have gone into building this thing out for us. So let's at least show it off a little bit. The home page here you're staring at, we've got an electronic workbook that is alive and well in the VM. It's got step-by-step instructions, kind of expandable and collapsible hints and commands that you can copy and paste as you work through all of the different environments that we've got put together. In the very first morning, what you do when you log into this thing is you pull down a nice little code repository from the locally running GitLab server that has enough Terraform in it to keep you busy for months reading through all the different resources in there. All of the Terraform, it's multi-clouded, right? So there's Terraform for AWS, there's Terraform for Azure, there's Terraform for GCP, and you don't need to understand what all's going on here to take the course or to have fun in the course. But just by doing the lab exercises, you are going to be exposed to it. And I suspect a lot of the students that take it will be not experts in Terraform by the end of it, but you will be very comfortable reading it and navigating through that technology as far as just cloud infrastructure goes. So while we're in this Terraform code, Brandon talked about IAM earlier. So I figured I would show you a couple of examples of some of the very tightened up IAM policies that we eventually launch into your cloud accounts as you take this course. Now, the first one that I'm showing you on the screen here, let me zoom in on this little fella here a little bit, and we'll talk about this for a second. So on this particular IAM policy, this is an AWS one. And what we're really concerned about in terms of service accounts or instance profiles being used on an EC2 instance is, are we restricting where those commands can come from? One of the more common attacks for an attacker, as you can see in the principle, we're running this particular encrypt and decrypt permissions from an EC2 instance. Now that commands, those command sets should only be run from inside of an Amazon VPC. So if I attack that instance and I steal the credentials off of it, which has happened in some very popular and commonly discussed breaches out there, should I be able to run those commands from my laptop here in Iowa? And by default, you can. But as you dig into the IAM principal documentation, notice this condition on the bottom where we're going to add this very concise but yet very powerful IAM condition that says, look, on the incoming request with these credentials to encrypt or decrypt something, we're going to restrict that action to only a source VPC where the application is running at. So you've now locked down where those calls can come from using, what's that, what, 4 lines of Terraform to create that condition and lock it down. Super powerful concept, something that if we had all the time in the world, we would do all of the things with our IAM policies. But as we know, sometimes you're just happy that it works, you get it up and running, and we get moved off to the next thing. So we'll go through a lot of those different, very exciting permission lockdowns on the first day. So let me jump into this one. Brandon also talked about taking a managed Azure role, for example, where in this case, let's just say we're using the Azure, read or write role. But we have the capability of constraining the scope for those. So in a very similar fashion with the assignable scopes in this Terraform snippet, we'll reduce the resources that this particular role is allowed to use. So notice we're just limiting the scope to a documents container, a backup container, and it's got to be in that current subscription. So that's the way that you can use assignable scopes over in Azure to do that. As we flip to GCP, I did want to dial in, and Brandon even had this in his slide, so I won't spend too much time talking about this, but this is how you can do resource level binding over in the GCP side. So if you assign a role at the project level, you can get yourself into trouble because that role applies to all resources in the project. And what GCP is pushing us towards is actually saying, look, why don't you assign these permissions at the resource level? So here we're setting a key IAM binding. So this is a resource level binding on a KMS key. And we're saying, look, this KMS key is only accessible to the storage service account. And we're now locking down what that can do a little bit. So a little tour through some Terraform and through some IAM permissions to figure out, are we restricting privilege as much as we can inside of here? Okay, so enough with the infrastructure code. We get it, right? You all are pros at that now. Let's do some command line stuff because that's always fun as well. So Brendan also talked about doing some logging analytics. So as you venture off into the lab exercises at one point, we turn on the flow logs for everything. And one of your missions is to go in there and try to identify some malicious traffic. Now, I'm not going to give away what the malicious traffic is because that would ruin the lab for you. But what I do want you to see is some of the command line kung fu that you're going to get exposed to in the course as well. Now, this looks gross, right? And it probably took us forever to write it. Honestly, I can't remember who wrote this one, Brandon, but it's a long one. But what you're going to get exposed to, yes, we will use the Amazon, the Azure, and the Google command line interfaces to do some interaction with the cloud. So gcloud logging read, we're looking for flow log data here. And you're also going to see a lot of different JQ queries. So we can slice and dice our JSON that's coming back up into bits. Let me go ahead and run this thing. Ultimately, what we're looking for here are traffic patterns rolling through the network interface on one of our VMs. We're going to filter down to a certain subset of ports, and then we're going to use JQ to format that and show us essentially just the source, destination, protocol, and the ports that we're running on here. So you can see it took a little while for that to run, right? There's a lot of processing going on, but it's formatted very cleanly so you can see exactly what this data may or may not contain during the lab exercise. So that's an example of some of the command line action that you'll get into. I'll flip to a web interface now for those of you that are command line averse. There's something, there's a little bit of everything in here for everybody. So I'm also looking now at Azure Log Analytics. And what you're going to do, let me zoom in on this just a touch here, see if I can make that a little bit bigger. Actually, let me kill this off. Oh, no, I don't want that. There we go. Now you can kind of see the query. The Custo query you're looking at, this is KQL, which is Azure's query language in their analytics space. Let me zoom in on this just a touch. So we're querying the network's analytics table inside of Azure Monitor Logging. And we're filtering by a specific source IP, looking for network security group, deny outbound calls, and we're querying out basically the public IP it's headed to, the protocol, and then let's run this little fella, and you can see the results come back down here. Now, it's a little bit more difficult to parse, in my opinion, in this case. JQ could format this a lot better, I think, but we'll also get you into some of the web consoles and show you where the equivalent, here's the command line way to do something, here's where you're going to do it through the web interface. So a little bit of flow log action there. I would be remiss if I didn't show you, now this is the Azure flavor of the Nimbus Immutable website that you will be launching into all three clouds. And most of our activity, the flow logging, the storage buckets, there's a backend database involved here, there's lots of crypto keys doing crypto operations, are all being used kind of under the hood by this website that you'll interact with quite a bit during the class. It runs in all three. So Brandon architected it so it knows which environment it's running in. So you can use the AWS version to talk to S3. You can use the Azure version to talk to Azure Storage. You use the GCP version to talk to GCS. And then on the last day, we actually start doing cross-cloud communication between the three different sites. So at one point, you'll pop in there and you'll be able to log in with a centralized Azure AD principal from AWS. So we'll do some single sign-on through the application and do some other fun things as we really explore that multi-cloud component of the lab environment. A couple other fun bits I'll show you here while we've got a few more minutes. If I pop off over into the next tab, let's sign a URL out in AWS. So this is one of the other exercises you get to play with. So we'll pre-sign this URL in S3, which really hardly anybody looks for from a data exfiltration perspective. We can open this thing up, and I'm going to give away some secret sauce here, but I'm showing you a super secret, highly confidential memo that's buried inside of an S3 bucket. I'm going to make some very quick requests for this here and then close it so you can't read what's going on inside of it. And as we go through that, we can then start doing some investigations into logging on the storage side. Can we actually see that happening in our log data? So we'll do some more command line kung fu here. We're going to query the AWS log service, look for different events that are going on related to, and this is very subtle, and Brandon, I'm pretty sure we struggled to find even a signature that indicates that this was coming from a signed URL. So you're looking for very interesting pieces of data in the request to find those things. We'll start looking at the logging results and suddenly, oh, weird. Yeah, there's that anonymous request with a signed URL. They came in looking for that corporate bucket and trying to steal that memo.pdf file out of there. So different ways that we can find those signed requests coming in, which we talked about. On the final side, I'll just show you, in case you haven't seen them before, kill this tab off here. I'll start with Google. This is Security Command Center over in my GCP org. Unfortunately, most of the students that show up for the class will have a Gmail-based GCP project. And there's a limitation there. You have to have an org to set up Security Command Center. So I'm in my organization, my playground that I use for things. And you can kind of look through this. here's some threats. Eric has some bad practices going on where I've got some open firewalls. I've got an open RDP port and the default firewall rules, which we'll go through. Brandon actually threw some Terraform into that repo that goes in and just wipes out all of those default firewall rules for us at one point during the class, which is pretty fun. I'll flip to Security Center. Here's the equivalent dashboard over on the Azure side. So we've got regulatory compliance. You can see I actually just turned Defender off the other day because I realized it was charging me like, I don't know, 60 or 70 bucks a month to keep it on. So we'll try not to do that at the end of the class. You have a massive stack destroy command that you run on a Friday before you head off for the end of the weekend or for the weekend. And that'll hopefully stop the bleeding on the Charters side and tear all these resources down as the class comes to a close. So just a quick run through the ecosystem and everything, not everything, but a good tour through a lot of the different resources that you'll get to play with as you tour this lab environment. So with that, Brandon, I'll throw it back to you to close us out here, and then we can open it up for questions.
Oh, certainly. Thank you, Eric. And I know that you said everything is covered here. Very far from it. It's hard to believe that this is just scratching at the surface of all the things that we found in the process of creating this course. I mean, we just found a lot of things that honestly we didn't even know going into the development of this course. So I really hope that you can join us for one of these future sessions of Sec 510. If you like this webcast and it was valuable to you, you would get so much value out of Sec 510. We've had the pleasure of having a couple runs of our 3-day version of the class, and here are some of the reviews we got from our first beta ever. And right out of the gate, it was a class that a lot of folks enjoyed. We had a couple other runs of the 3-day version of the class, and next month we are having our debut of the 5-day version of the class. We go into a lot more depth about storage. We go into a whole lot more depth about serverless and talk a little bit about Google's very rarely discussed but incredibly important serverless service called Firebase, which a lot of you may have attended my Tech Tuesday on. You may have noticed that the same chat window from that Tech Tuesday was featured in the lab environment. Maybe there's a little bit of a reuse of that code there that you've maybe seen in the past. And if you didn't make it to the Tech Tuesday, this is your only chance to check it out. So I really hope that you can join us for that. And of course, the multi-cloud integration, the cross-account stuff, the cloud identity providers for users, single sign-on, these different security centers, all of that's covered in day 5. It is brand new content, but all of the content from the 3-day version is still included. With that, if we go to the next slide, we have a lot of resources that are free that can talk to you about, they can give you more details in more depth about these various subjects. We have a lot of free resources on sans.org/cloud security, a poster that contains some of the content from Sec 510, a command line cheat sheet that would be valuable for you if, for example, if you ever have to take a certification that involves the different CLIs, maybe that'll happen in the future, who knows. If you want to learn more about the content we have here, we have several webcasts and blog posts and white papers that go into a little bit more detail about that. And then finally, to tie this off, we had a webcast right before the 3-day version was released. And if you haven't checked that out, you should definitely check it out as well, because we covered different subjects in that webcast. We went really deep into one particular topic, separate from what we discussed in this webcast. So that content from the 3-day version is still in the course. It is still incredibly relevant. So if you need a little bit more content to justify making the push to check out the course, please check it out and show it to your management, because it's covering a subject that has really been hurting the enterprise over the past 2 or so years, and no one is talking about it to the same level that we are, honestly. And with that, thank you so much for taking the time out of your day to attend this webcast. We'd love to take your questions. And so far, we actually have 2 questions already queued up. Firstly, I'll answer, is Terraform a common language just applied differently based on cloud provider. So Terraform is an infrastructure as code tool that uses a language called the HashiCorp Configuration Language, or HCL. I believe that's what HCL stands for. And it has a variety of providers. So there's a provider for AWS, a provider for Azure, a provider for GCP. There are also providers for on-premises equipment. So there's a whole lot of different services that you can configure with that consistent configuration language in the Terraform product. Someone else asks or commands that we talk about certificate authentication. I'd love to learn more about what specifically you'd like to learn about. One interesting thing related to certificate authentication is that in Google, when you want to do when you want to enforce SSL for your database connections in Google Cloud SQL, one thing that I found really interesting is as soon as you turn on that setting that requires TLS for Google Cloud connections, all of a sudden you have to do client certificate-based authentication, which is kind of weird. Those are normally two different settings. They're both valuable, but in Google you have to do both or you can't have either, which is kind of interesting to me. But if you have a more specific question about certificate authentication, I'd love to go into more detail. Any other questions, comments? I saw some folks are already signed up for our 5-day debut, so I'm really looking forward to seeing you next month. So David asks, is there a security case to encourage staying within a single vendor? We actually talk about this a lot in our introduction, the business case for multi-cloud and why you would go with multi-cloud or not go with multi-cloud. And we have a lot of arguments for why multi-cloud can be useful. But here's the important takeaway for you all, is that if you're working in security, you are almost certainly not making the decision of what cloud providers your company uses. That is largely determined by a variety of factors outside of our hands. What do the developers want to work with? What's the best pricing model? So you can argue, hey, don't use multiple cloud providers. And in many cases, you might end up being more secure that way. But at the end of the day, you have to secure the infrastructure that is created by your product development organization. And oftentimes they're going to decide to go multi-cloud whether you like it or not. My pleasure. Any final questions? I know it's pretty late for those folks who just took a course all day. I know Eric's exhausted.
Quiet tonight.
Eric, you're teaching 540 this week?
Yeah, I am. Hey, Steve, how's it going, buddy? Good to hear from you, man.
Steve. Good to see you. Steve and I are former coworkers. All right, I think that's it for tonight. So thank you so much for attending. As stated before, I think I stated before, I'm Brandon Evans. This is Eric Johnson with me. We are the co-authors of Sec 510, and we have several runs scheduled for the next couple months. If you can attend one of those, we'd love to have you for our live online offering. If not, we will also be publishing an on-demand version of the class shortly after the debut, so you can take it at your own pace. Either way, we'd love for you to learn more about this area, and I hope that you enjoy this material and the course as much as we enjoyed creating it.